Hello friends and students and parents, welcome to Concept Clarity for Physics. Today's topic is going to be a very important topic, that is vectors. Entire physics is revolving around this particular topic, vectors. It will be extensively used in the later on chapters, so you have to pay very clear attention, careful attention to vectors. So in physics we have two physical quantities. One is a scalar, another is a vector, right? One is a scalar quantity, another is a vector quantity. So what is the scalar quantity? Scalar quantities are those which can be only represented by magnitude. That means the physical quantity which can be specified by just magnitude. What? By just magnitude. These are called as scalar quantities. Magnitude means, what does magnitude mean? Magnitude means a number. Okay. For example, we say 5 meters or we say 2 kgs. These are all scalar quantities, right? 35 degrees centigrade. They are represented by just the number. Okay. So, so examples what you can see here is related to distance. This is a distance, is a scalar quantity. This is the mass, scalar quantity. Temperature, scalar quantity. Then you have various other quantities, for example, like you have energy, volume, density, electric charge. These are all scalar quantities. Scalar quantities can be added, subtracted or multiplied by the laws of algebra. Okay. Scalar has magnitude, it can be represented represented by a number. It can be added, subtracted or multiplied or divided, right, as per the laws, right, laws of algebra. Okay. Now if for physical quantity, let us go to the next part. I'll clear this. This is for scalar. If a physical quantity, now we are going to talk about vectors. Okay, this is going to be about vector. I'm going to define. If a physical quantity has magnitude and what direction also, not limiting it, but also obeys commutative laws of addition, What does commutative law of addition means? If I do A plus B is equal to B plus A, that means the order doesn't matter, both mean the same thing, and also obeys laws of vector addition. This will be discussed. This will be discussed. To be discussed. To be discussed. Only then it is a vector. Victory vector. Okay. So vector has magnitude and direction. It should obey the commutative law and should also obey vector law of addition and subtraction. So graphically, let's see how vectors are represented. I will clear this. Graphical representation. Of what? Vectors. So you will have direction, it is represented with an arrow with a head. This is called as the head, and this is the tail, and this is showing the direction, and it has magnitude also. This shows the length of the arrow. The length of the arrow, that means from here to here, the length of the arrow indicates the magnitude. Length of arrow is equal to magnitude. Magnitude of what? Magnitude of the vector. TUDE. DE. Okay. Direction of arrow shows the direction of vector. Right? Mathematically, a vector is denoted as A with an arrow on top. So let us see some important points of vector. I will clear this. Important points. Important points for what? Vector. The first important point is, if you have one vector like this is A, this is another vector C, then you have a third vector B. Here A vector is equal to B vector is equal to C vector. That means a vector does not change if it is displaced parallelly to itself, as magnitude and direction of the vector remains same. What is said? A vector does not change if it is displaced parallel to itself. As both magnitude I'll write the full thing, and direction remains same. Here vector A is equal to vector B is equal to vector C. Next important point, if I write vector A and if I put side bars, then this is called as the modulus of vector or mod A, modulus of vector. This simply gives the magnitude of vector A. It gives just the magnitude of vector A. Multiplying a vector, A with a positive number, let us say the positive number is beta, gives a vector, another vector called B, which is equal to the magnitude of vector A increased by beta times A. That means the magnitude of A has changed by a factor of beta. So, if A was like this, represented graphically like this, then B became a larger representation. This B is basically B times beta times A. Next rule, next important point, I will clear this. A vector with the same magnitude, let us say this is a vector A having some magnitude, okay, and another vector in the opposite direction having the same magnitude will be shown as minus A, okay, is shown as minus A. Same magnitude but different direction. Next is if a vector is rotated by some angle theta other than multiple of 2 pi, then different vector is formed, as the direction of the vector has been changed due to rotation, as direction changed. Why? Due to rotation by theta degree. So, if we had a vector A and this vector A is now rotated, then you will get a new vector B, which is having a new direction, right? A has this direction and B has another direction. So, the direction has changed. If the vector is rotated, then a new vector is formed with a different direction. These are some of the rules of vectors. So, let us summarize this, whatever we have studied. Okay, I will clear this. Let us summarize. So, in physics we have two quantities, two types of quantities rather. I will clear this again, summary. Two type of quantities, and what are the type of quantities? One is a scalar, that means scalar has just the magnitude, and vector, which is little more in detail. Vector has magnitude, it has direction, it obeys commutative law, and vector law as well. It has to follow all these laws, then only it is called a vector. And then we have seen some important points of vectors. What are some of the important points? We'll put here, we'll graphically represent here. This is a vector. This is a vector which has a tail and a head, and this gives the direction, and the length of the arrow will give the magnitude. Okay, important point is, if the vector does not change, if it is displaced parallel to itself, then the vector remains same both in magnitude and direction. If you have A, C, these are all parallel, right, and the direction and magnitude is the same here. So vector A is equal to vector B is equal to vector C, right? And if a vector is opposite, to direction of A, the magnitude is the same, then this is represented as minus A. If the vector A is rotated by an angle of theta, right, this will produce another vector called, let's say, D, right? It will produce another vector D with a different direction. These are some rules which we have studied. So with this we understood basics of vectors. Next we are going to see how vector additions are done. Okay, in our next class we will see how vectors are added, and subsequently we will solve some problems on vectors as well. See you until then. Like, share, subscribe.